Hi, my name is Everest Sapabio. I major in computer science and minor in MIS at the University of Central Oklahoma. In this video, I'll be giving a high-level overview of the design phase of a software development lifecycle, showing you how one would go about demystifying the specifications of a new system. Say you did some planning and analysis and decided that blockchain would be the best fit for your new or upgraded system. In an agile setting, now would be the time to create a minimum viable product. Let's look at the definition of blockchain. So, a blockchain, original blockchain, is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data, generally represented as Merkle trees. Okay, so cryptography is mentioned a lot when talking about blockchain, and people automatically bring up cryptocurrencies like Bitcoin, but the use cases for blockchain spans way beyond that. It's a concept that's no different from an algorithm or a design pattern. It tells you how these pieces should work together, but not the exact implementation. In software, this is called abstraction. So let's try to simplify these words and just turn them into conceptual models. Working with new technology can be difficult and the documentations can be verbose. So when looking to create a minimum viable product, it helps to pick out essential components of that system and build upon it. So this documentation on blockchain is very well done, and we could pick out these components in the first paragraph. Okay, so we'll say it says a blockchain is a growing list of blocks, and each block contains a cryptographic hash that links to the other block. Okay, so we could create entities from that. So let's say a blockchain entity, and says it has a list of blocks. Okay, so a block here would be a different entity. Say block, and it has, this is an attribute of blockchain, and we would just find attributes or properties of a block, and it says here it needs a hash of the previous block, and hash of the current block, because it needs to reference itself. Okay, so in an ER diagram, you would, in a SQL join, this would be a self join, and this would be a foreign key, and that would be a primary key. So it also needs a timestamp and transaction data, like a list of transactions maybe. So transaction here would also be a different entity. And if you just look at the next line, and says it can record transactions between two parties, so I would just say a sender and a receiver. Okay, I do have a better representation of this, so let's go to Visio. Okay, so we have blockchain here, conceptual data, chain of blocks, and we have a block, hash of the previous block, hash of the current block, just reference itself, a timestamp, and transactions. And the transaction model has a sender's address, a receiver's address, a timestamp, and data. Okay, let's look at a more logical diagram here. Defining a few data types, we could say the chain of blocks could be an array of blocks, and a block would just be an object or a class. It has a hash of the previous block, SHA 256, not 254. So that's just a hashing algorithm. We'll take a look at it in a little bit. It has a timestamp, which is a date time, and has an array of transactions. It's a transaction object, a string, sender's address, receiver's address, timestamp, and data. And so after looking at this model, we have what blockchain does is it just gives you this conceptual definitions, and it can be extended upon. This is called the open-close principle in object-oriented programming. It says an entity is open to extension but closed for modification. So as long as you have this base specifications of a blockchain, you could extend this depending on your business rules to do whatever you want. So for this blockchain, I might want to add a method called create genesis block. Okay, since we've noticed that we've established that every block needs to reference a previous block, so it needs to start from somewhere, and we would create a genesis block. It's usually zeroed out values that every other block would reference from. Okay, that would have the first hash. I would create a method called create genesis block here, and then maybe verify blocks, because if you look at the block section, it says this iterative process confirms the integrity of the previous block by going all the way back to the genesis block. So you could implement a method that could verify a block by comparing its hashes all the way to the genesis block. Okay, so we also have data as part of our transactions, so we could define what data is for an application and how we're going to secure that data. That's what we're going to do next. So before we get into some code on how we would store and secure data, I would like to show you a concept I worked on with Dr. Cheng called BioShare. Okay, so BioShare would be a way of using a private blockchain to secure data. Something like an image from a crime scene can be photoshopped and no one would notice, and that's evidence that could make or break an investigation. Okay? The idea was that a crime scene technician should be able to upload data to a database, and the data would be encrypted and on the network. So anytime the data is shared, a transaction is recorded. Okay? And that way the data can be tracked and verified when needed. As you can see here, this user interface, it has Alice, the crime scene investigator, and if you just two users here on the network, and we have a ledger, we would call that a blockchain, and we have a genesis block in there. So everything is just zeroed out, but it has a hash of itself. Okay, so other blocks are going to be referencing this hash. It has all the properties of a blockchain. That's timestamp, and it has transactions. Okay, so it's really small, but that's a timestamp, and this is a transaction. It's an array. It has a timestamp, the sender's drive, receiver's drive, the file count, the previous hash, which is zeroed out because it's the genesis block. It has a nonce value, and that's usually used for cryptocurrency to add some level of difficulty to the hashing algorithm. And this is the actual hash here. Okay, so the concept would be I could share data, let's say fingerprint. I could share it to Bob, and if we look at Bob's drive, we could see I have that fingerprint shared with him. Okay, and it added a block to this chain. We could see the hash, and in a fully realized version, it would be the encrypted data also showing up here. Okay, so I also added a business rule to this since it's extendable. Blockchain is extendable. So in my system, you're not allowed to share data another person already has. Okay, so since Alice already has the fingerprint data, I cannot share fingerprint with Bob anymore, but I could share it with someone else. Okay, just reduces redundancy in the system. Okay, let's look at some code actually. So how will we go about securing data, like digital data, images, or whatever? Okay, let's look at a base64 converter here. This is a library. It converts images into a binary data, so you're able to store it in a database. Okay. Okay. So let me show you what the image is. The image is just a nice skyline at towers. So what this function does is it takes that image. This is a path to that image. it takes it in and converts it to binary data. And what this does is it saves that binary data to a text file. So let me just run this. Okay, you could see it created a text file. Let me open that up here. All right, so with this text file, that beautiful image you just saw is just represented as text, hexadecimal. This is the hexadecimal representation of it. This is what you would store in a database, okay? So the computer itself actually reads all this as zeros and ones, but this text file, it's easy to store in a database and share it. So what I'm gonna do is just copy all of this in just to show you that this is an actual representation of that image. I'm gonna put this in a web document, okay, and just create an image tag. Okay, so I'm just gonna paste, let's see, I'm gonna close this tag here. I'm just gonna paste the value of that text I just copied as the source of this image. Okay, I'm gonna save that and I'm gonna start this up in my browser. Alright, so that's the actual representation of that image just from a binary document. So if we inspect that, we could see. So that's the actual text data I just pasted in, and I'm able to view it on an interface. So that's basically how you would store data in a database. Let's talk about cryptography. So cryptography, simply defined, is a way of securing data during transmission or storage. Okay? And there are two popular cryptographic functions, and that's one of them is hashing, the other is encryption. A hash is a one-way crypt function and the data made with hashes cannot be retrieved. So the use case for a hash would be for passwords or a reference to a link, just like the one we have in our blockchain application. This would be hashed, but the data itself would have to be encrypted, since we need to get the actual data back at some point. Okay, so hash is a one-way street. Data can be retrieved. In encryption, data can be retrieved using some sort of a key or something. Okay, so if we have a message, we should probably change this to a password or a link reference, but a message wouldn't be the best use case for a hashing algorithm. But let's just say we have a message and we wanted to hash this message, and we would never retrieve it. Let's just run this function here. So this is a library called SHA-256. A variable called message says hello, it's a string, and this hash message would parse this message as an SHA-256 value and just output this to the console. Let's run this. Okay, so we have that cryptographic hash right there. This would be a hash of one of the links, maybe. Okay, so the way passwords are stored in a database is that once you enter your password, it's stored as this hash. So even if I'm the admin of this system, I cannot log into your account because this is the only data I'm going to be looking at, and I cannot reverse this to get your actual password, which is hello. So if I do something like a console.log, so I'm going to be testing for equality, saying that this hashed message is equal to, if I check that this hash message is equal to this should return true because this is the value stored in the database. And if I enter hello and it hashes it, it's going to give me this exact same value, and I would be able to let you into a system. Okay, so run this. The value should be either true or false, and we could say it's true, so that's a valid password. So as an admin of a database, this is all I get from my end. So if I don't know that your password is hello. If I decide to enter this hash right here and run it, I would get a value of false. That's because this message gets hashed again, and the return value of this hash wouldn't be the same as this. Okay, so it's a totally different string. That's what hashing is all about. Okay. Okay, it seems like we have all the pieces we need. So we have our data, we have a way to convert data, we have a way to secure data. We would actually use encryption instead of hashing to encrypt that data. But we have a way to hash our links, our references to other data. Okay, so let's go back to Visio and just look at this. So we have everything we need from our programming language. We have a chain of blocks. That's array. We know how to hash our blocks, and each block would just reference is a link to the previous block. So mostly like a self join, where this is the primary key and this would be the foreign key. We have a timestamp, which is calculated by a date time function. We have an array of transaction, string, date, time, and I just showed you how we would go about storing data. So now that we've designed some components for a blockchain system, let's see how we would actually implement that with programming. So I'll be using JavaScript, this JavaScript here, and this is a implementation I've done in the past. We're gonna just go over it. So we have our transaction object here. You could see it's a class object. And what this constructor does is that it is called once an instance of a transaction has been made. Okay, so since we said we require a timestamp, a sender, a receiver, and data. So in this case, this was a cryptocurrency simulation. So I used amount instead of data. Okay, so we have that in the constructor. So anytime I need a transaction, I need to pass these fields, which are initialized for this transaction. And I also have a block here, single data object, pass the timestamp, transactions, and previous hash, just like we've defined here. Previous hash and its current hash will be calculated. See, I'm using a method right here. We're using that SHA to generate its current hash. Okay. I think the constructor is what you need to focus most on, because this methods are just different implementations. You have to decide how you want to implement that on your own application. Okay, and we have the blockchain object here, have a constructor, says a chain and difficulty and a lot of stuff that would be specific to a cryptocurrency application like airdrop coins. But okay, we also have a method called create genesis block. So this just creates the first instance of a block. See, everything is just a zero value here. Okay, so to test this code out, I'm creating an instance of a blockchain, and I'm creating a transaction since I have a create transaction method here. And that create transaction takes in a type of transaction, and I'm instantiating a transaction. Have a date. Transaction requires a date, a sender, receiver, and the amount. So I've made two transactions right here. And I have a miner. That's a person who earns some credits for mining this transaction. And I'm outputting the addresses of these users, and I'm just showing off their balances in the system. Okay, and I think we'll just test it for one block and run that. Okay, so we've seen a hashing going on. A block has been mined. 3 transactions has been validated. So the first transaction is this. Second one is this, and the third transaction was the miner actually mining these 2 transactions. So that's 3. And it's hashed in a single block. So a block can contain a number of transactions. So it's hashed in a single block. And outputting their balances. So everyone had $100 initially, Alice sent 50 to Bob, and Bob sent 25 to Alice, and the miner received $50 for mining that transaction because it's been specified as his mining reward. Okay, so that's how you go about making a blockchain application. And of course, you would need a user interface so it looks nice for everyone. I did make one called Alchemy, I think. So this is it. It's really similar to the other one. So let's shared 50, added this to a transaction, and he decided to share 25, adds that to a transaction, and I'm just going to mine this. Okay, so we see we have a Genesis block, zeroed out values. We can see Alice's transaction. We could see properties like the amount and all that, and we could see Bob's transaction. So the amount he shared was 25 right here. It's really hard to see, but I have links to all this in the description. You could go check it out for yourself. As you can see, blockchain is a simple yet solid concept that ensures that data is immutable, trackable, verifiable, and decentralized. That last one was a feature we didn't talk about, but blockchain provides a few basic entities, just like we've seen, that you can build upon when creating a secure system. And that will be all for this presentation. I hope you found it informative.